Hello, this is a C API update by Ryan and Matthew, and I want to start this update by going over the motivation behind the problem. And we have two types of problems that we aim to tackle, and one is when the signed detectors are too specific and not enough users were pinged, and the other is detectors are too general for people to participate in. The experience that were not complete end up being stuck in a limbo where the experience was just never complete, and it would give users the feeling of dissatisfaction when they look at all the incomplete experiences. So there are general ways to approach this problem, as we tackled mainly how we can manipulate the detectors to relax the completion needs. So the first approach that we looked at was adding technical support for being able to incorporate multiple detectors into an experience. And the second approach that we had was, instead of replacing the old detectors with an array of new detectors, simply replace it with one single detector that can encompass more circumstances. And the problem with this approach was that developers can't really specify the multiple specific circumstances for experiences, unlike approach number one. They can only specify a more general need. Another problem with this approach was that needs for experiences will become more vague and general, and it could potentially decrease the quality of the matched experiences if the user circumstances aren't that similar. And then the third approach that we looked at was implementing the method that allows for merging of multiple detectors into one single detector that is done by the platform instead of the developers. This approach was sort of good because developers didn't have to do much, and then developer interface didn't have to change that much, because developers still specify a single detector they want for the experience. For example, let's say if you want a party detector, then you would have something like that in the example, where the party detector will encompass all of the detectors in this example on the right side. But the problem with this is that the CE platform will have to write more detectors by merging other detectors manually, and considering all possible circumstances for developers would want for their detectors. And also vast amount of similar detectors could make it hard to navigate and find the right detectors as well. So we decided to go with approach one, since it has a flexibility where it can allow for developers to easily specify multiple specific detectors that they want included in the experience. And this aligns strongest with our main goal. And this is not very straightforward, because as we must figure out how we would relax the contribution needs and when we would make the relaxation, and figuring these out was technically difficult to think about. For the next part, I would like to summarize our contribution to the project. So our main motivation behind implementing this feature was based off of our future direction document, as our colleagues have previously done an adequate research for the topic, as well as for the needs for the feature. And we mainly focused on implementing the feature, so we made various changes to the internal functions of our code base to include features that allow developers to customize the relaxation process. Our feature revolves around developers being able to customize the relaxation time and scopes. So as you can see here, you can have time to expire, where developers can input how many seconds the experience will take to trigger the relaxation process, and type of detectors that developers want to include that will be used in the relaxation process. So let's actually go ahead and look at one of our storyboard example, and this is a pretty common example in our API, which is scavenger hunt. And let's say we have a user named Boris who gets pinged with an experience based on his circumstances. Follow the cursor if you can, because it can be a little hard to follow. And Boris is currently drinking a beer and eating a burger in a restaurant. So Experience uses restaurant detector to ping users in restaurants, but few participate since not everyone is eating burger and drinking beer at the same time in a restaurant. So this causes to have not enough users participate, and the experience just become incomplete, and the experience is stuck in a limbo. So ideally, we want to relax the needs so that we can find more people who are in the same circumstances. So API takes another detector, possibly a bar, to find more people who are in the same circumstances, because there might be other places that the people are drinking beer and eating burger at the same time. So the relaxation happens, and API is able to find more people who will participate in the experience, and eventually the experience gets completed as we look for more people who are in the same situation in different places with different detectors. So we can move over to our canvas here, and you can actually see two types of design arguments that we have here. So we mainly split into two parts where we talk about the quantity of the experiences and the quality of the experience. And relaxation of need can enhance both of these features of our API, since relaxing needs will increase the likelihood of people being able to contribute to experience, and this will increase the quantity of experiences completed for a user, and this will give the satisfaction to the user in the application. And relaxing needs also allows you to find more people who are in the same situation, because we can scope out and look for other detectors that can possibly where we can possibly find users who are in the same circumstance as well.
In order for us to relax the needs or the detectors of the experience, we set up the system model to incorporate a couple different components for each experience and their respective submissions. First of all, we keep track of the time elapsed since the first submission to the experience, and that is done by subtracting the current timestamp from the timestamp of the first submission. Secondly, the amount of time for the experience to qualify as expired, and we have a little specification in the interface model that allows developers to specify how much time they want to pass in order for this experience to be deemed as expired. Thirdly, we have like the past, initial detector for the experiences. And lastly, we also have a new field where the old detectors would be replaced and updated with a new detector if the experience was to ever be defined as an expired experience. And we also have a script that will run on the backend that will check and actually implement all the said and aforementioned commands for expiration of experiences if they are expired, and this script is would run and trigger if a user would to change their location, or if a user would to change their location, because we think this is a pretty contingent on this condition, because if a user changes their location, immediately they would potentially be exposed to newer experiences that we want to see if would fit the new circumstance for the user. And here we're going to give a quick technical demonstration. So now we're going to run a quick technical demo on C platform, as well as the new feature that we've implemented on C platform, and that is the relaxation of detectors for experiences. So firstly, we're just going to run Meteor on C platform real quick, just to get it up and running. And while that is booting up, I will quickly explain the simulation today. So first of all, we've written a sample experience called Complete a Menu, where it's a scavenger hunt of typical items you'd find in a coffee shop, including coffee, biscuits, and cake. But these are things that you could find. You wouldn't necessarily only find it in a coffee restaurant. You could find it in a restaurant, for instance. And these detectors are the default detectors for each of these respective items. And here we have the backup detector, the restaurant ID, that replaces these detectors if this experience would be ever deemed as expired. And this is the time to expiration, which is the time after the first submission in which this experience will be deemed expired. Why is it 0? For the sake of just testing this experience, we're going to make it immediately expire after a location change. Immediately expire after the first submission. And the backend script that checks for expiration of experiences runs every time someone changes their location, because that is, we believe, a circumstance in which you would need to reevaluate the experiences that should be available to the user. So now if we go back here, we're just going to quickly simulate users' locations. So if you can see here, all users are burgers. They're all at a burger restaurant. And remember, since we checked the, since we made the detectors, sorry. Oh my God. Since we made the detectors coffee, so they should not be able to see this experience because they are actually not at a coffee shop, they're at a restaurant. But now if we change this to coffee, they should be able to see the experience because, you know, the default detectors are at coffee shops. So now that I'm at a coffee shop, I'm going to submit and contribute to this experience. I'm just going to submit a photo that would normally be a picture of coffee. I'm going to sign out right here. And let's take a look at the database and see what that looks like. So if we look at the database, let's find the experience that we just submitted to. Experience. So this is the experience that we just find. As you can see, this is the coffee shop detector. It still hasn't changed yet. And this is detector for the restaurant that we want to update this with as soon as this experience is deemed as an expired experience. So now let's go back and let's say these users move around. So now these users are at restaurants instead. So once these users are at restaurants, we reevaluate the experience, and because 0 time has passed, or at least more time than 0 has passed, this is now an expired experience. So what we want to do now is it updates the detectors. So if we run the exact same command, we see now the detectors, originally they were SAX something, which is the coffee shop detector ID. Now they are TR4E something, which is the restaurant detector ID. And similarly, if we actually go onto here and we sign in with someone else, right now their location is at a restaurant. They should now be able to see this because the detector has been relaxed, because the experience was deemed an expired experience. And now we continue on the task to finishing the scavenger hunt. Overall, we think that the implementation of our feature was pretty good and pretty robust in the sense that it met the needs and requirements of our design. It also benefits end users because it allows them to potentially get matched with more experiences and complete more experiences. And it also allows developers to really specify detectors that they won't need to worry that much about, because if it's too specific, it would also always have a safety net detector that it would be able to update with if, too much time elapsed without the experience completing. And we also have tested the feature ourselves, and the implementation seems adequately robust. We think that we can run some user studies for the platform and see how the results compare to past research studies. And we can also use this as a way to gauge, whether users were more satisfied with our feature implemented within the C platform or without. And based off of that feedback, we can then use that to refine our feature to make it better suit the needs or the expectations for users. And also, since we now have a way to keep track of the amount of time that experiences are, active, and we also have a way to keep track of, changing detectors based off of timestamps, we can now, achieve more different possibilities, and we think that these are worth exploring, potentially maybe temporal time-based experiences where as soon as X amount of time has elapsed since an experience, we swap out the detector for a blank detector. So this way, maybe the experience would only be active for X amount of time. These are just various things that we would be able to explore based off of the infrastructure of the feature that we created. And And in addition, some additional takeaways are: we think that our work this quarter increases the flexibility of detectors by relaxing them after a certain amount of elapsed time. And this actually also vastly improves the number of options that developers have, because now the developers can specify, a pre-detector and a post-detector to prevent limbo submissions and limbo experiences from happening, where maybe one user only submitted and nobody really contributed, leading to a bad user experiences for that said user. And obviously, the implications of flexible computation are broad. And in our specific feature and example, we think that it can actually improve user experiences by adjusting the flexibility of the detectors based off of time elapsed to allow more people to participate on an experience if there is a lack of user participation, which we hope ultimately will lead to a better and more positive user experience.